Good morning, students and parents. Welcome back to Mathematics 9 Valenzuela Live Streaming Class. Before we start our discussion, make sure your self-learning module is open on week 2 page. You must also have your pen and notebook with you. Are you ready? Let us begin. Our today's lesson is about joint and combined variation. At the end of this session, you should be able to illustrate situations that involves joint and combined variation. Translate into variation statement a relationship between two quantities given by a mathematical equation. Solve problems involving joint and combined variation. Last live session, you learned about direct and inverse variation. Let us check if you really understood the said lesson. Our first activity is entitled Represent Me. You will translate the statement that will flash on your screen. You will be given 5 seconds to answer. You can type your answer in the chat box. Use variable k to represent the constant of variation. Are you ready? Let us begin. Statement number 1. The cost C of fish varies directly as its weight W in kilograms. Translate into mathematical statement. Timer starts now. Time is up. If your answer is C is equal to KW, then you are correct. Statement number 2. The distance D traveled by a car is directly proportional as its speed S. 5 seconds to answer. Timer starts now. The correct answer is D is equal to KX. Statement number 3. The length L of a rectangular field varies inversely as its width W. 5 seconds to answer. Go. The correct answer is L is equal to K over W. If you got 3 correct answers, you are awesome. Let's continue on statement number 4. The mass m of an object varies inversely as the acceleration due to gravity g. 5 seconds to answer. Go. The correct answer is M is equal to K over G. For the last item, statement number 5. The area A of a square varies directly as the square of its side S. 5 seconds. Go. Time's up. The correct answer is A is equal to KS squared. If you got 5 correct answers, you are now ready to learn our next lesson. We will discuss today the other types of variation, which are the joint and combined variation. First, let us talk about joint variation. Joint variation is when a quantity varies directly as the product of two or more quantities. The statement y varies jointly as x and z can be written in the form y is equal to kxz, where k is the constant of variation. Now, using the concept of joint variation, let us translate the following variation statement into mathematical equation. You can type your answer in the chat box. The volume of a cone B varies jointly as area of the circular base B and altitude h. Key in your answer. The answer is V is equal to KBH. Very good, students. How about this statement? The force F applied to an object varies jointly as the mass m and the acceleration a. Type your answer now. The answer is F is equal to KMA. Did you get the correct answer? You're doing great. How about this one? The volume of a cylinder V varies jointly as its height h and the square of the radius r. Key in now your answer. The correct answer is V is equal to KHR squared. Did you get it correctly? Magnificent! You are now ready to the next level. So after dealing with translating the statements into mathematical equation, let us focus on the following problems. Example number 1. Suppose A varies jointly as B and C, and A is 24 when B is 3 and C is 2. Find A when B is 12 and C is 5. Step 1. Write the variation statement into mathematical equation. In example number 1, it says that A varies jointly as B and C. So we have A is equal to KBC. Step 2. Solve for the constant of variation. We will use the value of A is 24 when B is 3 and C is 2 to solve the constant of variation. By substitution method, we have 24 is equal to K times 3 times 2. Simplifying K times 3 times 2, we have 24 is equal to 6K. Applying the multiplication property of equality using multiplicative inverse, we multiply both sides by 1 over 6. We have 24 over 6 is equal to 6K over 6. Simplifying, we have 4 is equal to K, or K is equal to 4 using symmetric property. So our constant of variation is 4. Step 3. Rewrite the mathematical equation by putting the constant term K is equal to 4. So we have A is equal to 4BC. Step 4. Solve for the missing term in the problem. Since we need to find the value of A when B is 12 and C is 5, we have now A is equal to 4 times 12 times 5. Simplifying 4 times 12 times 5, we have A is equal to 240. Therefore, A is 240 when B is 12 and C is 5. Example number 2. If z varies jointly as x and y, and z is 60 when x is 5 and y is 6, find z when x is 7 and y is 6. Let us follow again the steps in solving joint variation. Since z varies jointly as x and y, we have z is equal to kxy. By substitution, we have 60 is equal to k times 5 times 6. Simplifying, k times 5 times 6, we have 60 is equal to 30k. Applying the multiplication property of equality using multiplicative inverse, we multiply both sides by 1 over 30. We have 60 over 30 is equal to 30k over 30. Simplifying, we have 2 is equal to k, or k is equal to 2 using symmetric property. Therefore, the value of the constant of variation is 2. Using the value of constant of variation, we have z is equal to 2xy. Since we need to find z when x is 7 and y is 6, we have z is equal to 2 times 7 times 6. Simplifying 2 times 7 times 6, we have z is equal to 84. Therefore, z is equal to 84 when x is equal to 7 and y is equal to 6. Do you understand now the joint variation? Very good. Let us proceed to the last type of variation. And that is combined variation. What is combined variation? This is the kind of variation that involves both direct and inverse variations. The statement y varies directly as x and inversely as z can be written in the form y is equal to kx over z, where k is the constant of variation. So again, the statement y varies directly as x and inversely as z can be written in the form y is equal to kx over z, where k is the constant of variation. Let us now try to translate variation statement into mathematical equation. Again, you can type your answer in the chat box or in the comment section. Are you ready? Okay, here is our first statement. The pressure P of a gas varies directly as its temperature T and inversely as its volume V. Write into mathematical equation. Key in now your answer. If you answer P is equal to KT over V, you are correct. Let's try the next statement. The electrical resistance R of a wire varies directly as its length L and inversely as the square of its diameter D. Write it again into its mathematical equation. Comment now your answer. The answer is R is equal to KL over D squared. Did you get the correct answer? You are now ready to solve problems. After translating variation statement into mathematical statement, we will now proceed to solving problems. Example number 1, in combined variation. If z varies directly as x and inversely as y, and z is 9 when x is 6 and y is 2, find z when x is 8 and y is 12. To solve this, we can use the methods earlier in joint variation. Step 1. Since z varies directly as x and inversely as y, we have z is equal to kx over y. Step 2. We will use the value of z is equal to 9 when x is 6 and y is 2 to solve the constant of variation. And by substitution, we have 9 is equal to k times 6 over 2. Simplifying k times 6, we have 9 is equal to 6k over 2. Multiplying both sides by 2, we have 18 is equal to 6k. Applying the multiplication property of equality, we have k is equal to 3. Step 3. Since the constant of variation is 3, we have z is equal to 3x over y. Step 4. Since we need to find z when x is 8 and y is 12, we have z is equal to 3 times 8 over 12. Simplifying 3 times 8, we have z is equal to 24 over 12. 24 divided by 12, we have z is equal to 2. Thus, z is equal to 2 when x is 8 and y is 12. Example number 2. Suppose r varies directly as the square of s and inversely as t. And r is 72 when s is 6 and t is 3. Find t when r is 12 and s is 2. Step 1. We have r is equal to ks squared over t. Next, by substitution, we will use the value of r is equal to 72 when s is 6 and t is 3. So we have 72 is equal to k times 6 squared over 3. Simplifying k times 6 squared, we have 72 is equal to 36k over 3. Multiplying 3 to both sides of the equation, we have 216 is equal to 36k. Applying the multiplication property of equality, we have k is equal to 6. Therefore, our constant of variation is 6. Using the value of the constant of variation we solve, we have r is equal to 6s squared over t. Since we need to find t when r is 12 and s is 2, so we have 12 is equal to 6 times 2 squared over t. Simplifying 2 squared, we have 12 is equal to 6 times 4 over t. 6 times 4, we have 12 is equal to 24 over t. Multiply both sides by t, we have 12t is equal to 24. Applying the multiplication property of equality, we have t is equal to 2. Hence, the value of t is 2 when r is 12 and s is 2. Did you get the way of solving joint and combined variations? Very good. You are now ready for the next level. Let us apply it to the real-life problems. Example number 1. The mass of a rectangular sheet of wood varies jointly as the length and the width. When the length is 20 cm and the width is 10 cm, the mass is 200 grams. Find the mass when the length is 15 cm and the width is 10 cm. If you observe the given problem, there is no variable that represents each quantity. So, you can use any letter to do this. The first quantity in the given problem is mass of a rectangular sheet. We can assign variable m for this. We will also use L to represent the length and W for the width. In order to solve this, we will apply again the steps we discussed earlier. In step 1, going back to our problem, the mass of a rectangular sheet of wood varies jointly as the length and the width. In symbol, we have M is equal to KLW. In step 2, when the length is 20 centimeters and the width is 10 centimeters, the mass is 200 grams. We use this information to solve for the constant term. So we have 200 is equal to K times 20 times 10. Simplifying K times 20 times 10, we have 200 is equal to 200K. Applying the multiplication property of equality, we have 1 is equal to K, or K is equal to 1 using symmetric property. Step 3. Rewrite the mathematical equation using the value of K as our constant of variation. We have M is equal to 1LW or M is equal to LW since the constant of variation is 1. Step 4. We need to find the mass when the length is 15 centimeters and the width is 10 centimeters. Substituting the given information to our equation, we have M is equal to 15 times 10. Simplifying 15 times 10, we have M is equal to 150. Thus, 150 grams is the mass when length is 15 centimeters and width is 10 centimeters. Let's try another example. The force attraction F of a body varies directly as its mass m and inversely as the square of the distance d from the body. When mass is 8 kilograms and distance is 5 meters, force is equal to 100 newtons. Find force when mass is 2 kilograms and distance is 15 meters. Step 1. The force attraction F of a body varies directly as its mass m and inversely as the square of the distance d from the body. The problem is an example of combined variation, and we can write it in symbol as F is equal to Km over d squared. Step 2. Since mass is equal to 8 kilograms and distance is equal to 5 meters, if force is equal to 100 newtons, we can now solve the constant of variation. By substituting the given in the equation, we have 100 is equal to k times 8 over 5 squared. Simplifying k times 8 over 5 squared, we have 100 is equal to 8k over 25. Multiply both sides by 25, we have 2,500 is equal to 8k. Applying the multiplication property of equality, we have k is equal to 312.5. Since k is equal to 312.5, our new equation now will be F is equal to 312.5 m over d squared. Step 4. In our example, we need to find F or force attraction when mass is 2 kilograms and distance is 15 meters. Substituting to our formula, we have F is equal to 312.5 times 2 over 15 squared. Simplifying, we have F is equal to 625 over 225. So, F is equal to 2.7 repeating or 2.8. Thus, force is 2.7 repeating or 2.8 when mass is 2 kilograms and distance is 15 meters. I hope you understand our lesson. To sum up our lesson today, we learned that joint variation is when a quantity varies directly as the product of two or more quantities. The statement y varies jointly as x and z can be written in the form of y is equal to kxz, where k is the constant of variation. Meanwhile, combined variation is a kind of variation that involves both direct and inverse variation. The statement y varies directly as x and inversely as z can be written in the form y is equal to kx over z, where k is the constant of variation. We have steps that we can follow to solve joint and combined variations. Step 1, write the variation statement into mathematical equation. Step 2, solve for the constant of variation. Step 3, rewrite the mathematical equation. And step 4, solve for the missing term in the problem. You can now ask questions. A question raised from one of our viewers: what is the difference between joint and combined variations? Joint variation is just like direct variation, but it involves two or more variables, like y is equal to kxz. Combined variation is a combination of direct and inverse variation, like y is equal to kx over z. If I was not able to answer some of your queries, you can ask your math teachers during your follow-up class discussions. For your home learning task, keep trying numbers 1 to 5 and what I can do numbers 1 and 2 on your self-learning module pages 8 and 9. Thank you for listening. See you in our next session.